Hello students, welcome back to the maths class. In today's class, let us learn about shortest distance between two lines. So here we are going to study two things. That is, the first thing is the distance between the two skew lines, and the next is distance between the parallel lines. So we already know what are parallel lines. So in today's class, first and foremost, let us understand what are skew lines. Skew lines are those lines which neither intersect nor parallel to each other, and such lines are also non-coplanar. Such lines are said to be skew lines. So here, when you consider the lines in a space, so here you can see line L1 and line L2 are parallel lines. Okay, and if you see line L3 and line L1, these two lines are neither parallel, they are not parallel lines, they do not intersect. Okay, don't think that if I extend the line L1 to line L3 it gets intersect. No, in space when I consider this, okay, these two lines, they do not intersect, and if you see, they are non-coplanar, they doesn't lie in the same plane. So such lines are called as skew lines. So the lines, those lines which are neither parallel nor intersect, and such lines are non-coplanar, and these lines are called as skew lines. Okay. So if you see line L1 and line L2, they are parallel lines. So L1 is parallel to the line L2. They are parallel lines. And how to find the distance between the parallel lines? By drawing a perpendicular. That is the perpendicular distance between L1 and L2. That we shall derive. Before that, we shall find what is the distance between the skew lines. Here, the skew lines are line L1 and line L3. Okay, you can see these two lines, L1 line and L2 line, are not parallel. They are not the parallel lines, and they do not intersect. And again, these lines are, they do not lie in the same plane. Such lines we call it as skew lines. So let us derive what is the distance, or the shortest distance between the two lines which we have considered. So let us find what is the distance between two skew lines. So this is important derivation. Again, this will be asked for 5 marks. Okay. So here I have considered two lines L1 and L2. Okay. These two lines are skew lines. What are skew lines? Those lines which are neither parallel nor intersect, and also they are non-coplanar. Okay. So we have considered two lines. That is, let L1 and L2 be two skew lines with equation. So the equation of this is given by, that is, the equation of L1 is vector R is equal to vector A plus lambda times vector B1. That is, vector R is equal to vector A1 plus lambda times vector B1. And vector R is equal to vector A2 plus mu times vector B2. That is the equation of L1 and equation of L2. Now what I am doing is, I am going to consider a point S on the line L1 with the position vector A1. So take, we are considering any point S on L1, on the line L1 with position vector A1. So the position vector of this is vector A1. Okay, then, and we are considering a point D on the line L2 with its position vector as A2, and T on the line L2 with position vector A2. Okay, so the position vector of point D is A2. Now, see, for the two lines, I have told you, when I consider this, okay, This was the line L3 and this was the line L1. So we told that these two lines are skew lines. The distance between the two lines here will be found by the perpendicular, that is the shortest distance will be always found by the perpendicular distance between the two lines. Okay, here. So when I consider two lines, so if these are two skew lines, okay, so take this and this to be our two skew lines, then the perpendicular. See, these two lines are neither parallel nor they're intersecting. If I drop a perpendicular between these two, means at only one point we can draw a perpendicular. So that will be the shortest distance between these two skew lines. So in this case, I've drawn a perpendicular. So PQ, if PQ is the shortest distance vector, okay, that is, then this implies that the vector PQ is perpendicular to the line L1 and the line L2. Okay, this PQ is perpendicular to both the line L1 and L2. And also, this also implies that vector PQ is perpendicular to vector V1 and vector V2. This you should imagine now. So here, when I told the line L1 and L2 have the equation, that is vector A1 plus lambda times vector V1 and vector A2 plus mu times vector V2, means this is the equation which we have derived for the line which is passing through a point and parallel to a given vector. So here the line which is passing through one point and parallel to a given vector means you have a vector B1, okay, this vector, and you have one more vector B2 which is parallel to the line L1 and vector B1, sorry, here, B2 and B1. So vector B2 is parallel to the line L2 and vector B1 is parallel to the line L1. So when these are parallel lines, again vector PQ will be perpendicular to both vector B1 and vector B2. Okay, this is the thing you should understand. Everything means the entire 3D we cannot represent it on the board. Certain things should be imagined. Now, we told that PQ is the shortest distance vector. So when I tell vector PQ means it should be both magnitude and direction. So let us write the magnitude, that is the length of this to be equal to t, and this in the direction of n cap. Why again I am telling you the direction here is along n cap? Because see, when I say that vector PQ is perpendicular to both vector V1 and vector V2. If you remember the cross product between the two vectors, okay, when I say cross, when I was explaining the definition of the cross product between the two vectors, the resultant of the cross product between the two vectors is along the direction of the unit vector perpendicular to both of them. So as PQ is perpendicular to both the vectors V1 and V2, so the direction of PQ is along the resultant, that is V1 cross V2 along n cap. So here, where n cap is the unit vector along PQ. Okay. So n cap will be given by B1 vector cross B2 vector by magnitude of B1 vector cross B2 vector. Therefore, we know that vector PQ is equal to D into n cap, that is the magnitude into direction. But we are interested in finding out only what is the value of D. So, magnitude of vector PQ is equal to magnitude of D into n cap. Therefore, magnitude of vector PQ is just PQ into D, where the magnitude of n cap unit vector is equal to 1. So, we need to find what is D. In order to find D, here we are going to use the concept of projection. This says that the magnitude of vector PQ is equal to projection of the vector ST along the direction of shortest distance. Okay, so magnitude of PQ is equal to the projection of ST. That is, what is the projection made by this vector ST in the direction of PQ. So if you remember again the definition of projection, we told that vector A dot vector B is equal to magnitude of A magnitude of B into cos theta, where vector A dot vector B by magnitude of B is equal to, sorry, magnitude of A is equal to magnitude of B into cos theta. This is nothing but projection of vector B on vector A, which is given by magnitude of B into cos theta. Okay, so if this is our vector A and this is our vector B, then the projection of ST in the direction of PQ will be given by, see, vector B is ST vector. So this is given by, we can write this as PQ vector dot ST vector by magnitude of PQ is equal to magnitude of ST into cos theta. So the projection of vector B on vector A, or projection of vector ST on vector PQ, projection of vector ST on vector PQ is given by magnitude of vector ST into cos theta. Okay, I'm going to use this in this. Okay, this, instead of writing all this thing, now I'm going to write projection of ST on PQ. This is projection of ST along the direction of the shortest distance. What is the shortest distance? It's nothing but the vector PQ. I have taken vector PQ as the shortest distance vector. So on that will be equal to magnitude of ST into cos theta. So we are not going to write this entire thing. So it is understood because we have already learned the concept of projection. So this will be equal to ST, magnitude of ST into cos theta. Okay, so magnitude of PQ is just PQ into ST into cos theta. Why I am writing only, when I write magnitude of PQ, means I am writing it as PQ. Why? Because magnitude means only the length. So when I measure it, we can even write it as PQ itself. So PQ is equal to ST cos theta. What is PQ? PQ is nothing but D. D is equal to ST into cos theta. So now we need to find what is cos theta. Here I am taking the magnitude for cos theta. Why? Because the distance when we are taking, it should be always positive. So let us find what cos theta is. So for that, let theta be the angle between the two vectors, that is vector PQ and vector ST. That means when you extend this line, somewhere these two lines meet and make an angle of theta. So let theta be the angle between vector PQ and vector ST. And we already know what is the angle between the two vectors, and it is given by cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. So here I am going to use the same formula where vector A is represented by PQ and vector B is represented by vector B. So it is vector PQ dot vector ST by magnitude of vector PQ into magnitude of vector ST. Okay, so what is vector PQ? Vector PQ is given by D into n cap into ST. Okay, here when I need to find ST is nothing but a vector joining 2 points. See, ST is a vector which is given by vector joining 2 points. How to find? Just subtracting this. So where ST is given by A2 minus A1. So vector ST, because here you can take out ST, vector ST is nothing but vector A2 minus A1. How did I get this? Because vector ST can be written as vector OT minus vector OS. Okay? Vector ST is nothing but vector OT minus vector OS, and I have already told the position vector for the point S is A1 and the position vector for the point T is A2. So this will be equal to vector A2 minus vector A1. Therefore, vector ST can be written as vector A2 minus vector A1 whole divided by, what is magnitude of PQ? Magnitude of PQ is nothing but D into magnitude of ST. For now, I'll just write it as ST itself. So here D and D get cancelled. I hope everyone have copied this. I'm going to wrap this and complete the derivation. So here when D and D get cancelled, next cos theta will be equal to, we have n cap in dot vector A2 minus vector A1 divided by ST. Okay, so let us substitute what n cap is. So if you remember, I wrote n cap as B1 cross vector B2 by magnitude of B1 cross vector B2. So substituting that, B1 cross B2 dot A2 minus A1 by magnitude of B1 cross vector B2 into ST. That is, n cap is given by B1 cross B2 vector B1 cross vector B2 divided by magnitude of vector B1 cross B2 dot A2 minus A1, this whole divided by ST. So now we came to know what is the value of cos theta, but what we are interested in? We are interested in finding the distance D. What is D? D is nothing but PQ. What is PQ? PQ is the shortest distance between the two skew lines. Therefore, D, which is equal to ST into magnitude of cos theta, which is given by ST into magnitude of cos theta is nothing but vector B1 cross vector B2 dot vector A2 minus vector A1 whole divided by magnitude of vector B1 cross vector B2 into ST. Now ST and ST get cancelled. Therefore, hence the shortest distance between the two skew lines will be given by D is equal to magnitude of B1 cross B2 dot A2 minus A1 by magnitude of B1 cross B2. Okay, this is the shortest distance between the two skew lines. I hope you have understood. Let us take a quick revision on this. So here what I have done is I have considered the two lines L1 and L2, and these two lines are what kind of lines? These are skew lines. What are skew lines? Skew lines are those lines which neither intersect nor parallel, and they are also non-coplanar. So we have considered the two lines, and the equation of those two lines is given by vector r is equal to vector a1 plus lambda times vector b1, vector r is equal to vector e2 plus mu times b2. After that, I consider a point S on the line L1 and its position vector as A1, and a point T on the line L2 with its position vector as A2. Then we told that PQ is the shortest distance vector. So if PQ is the shortest distance vector, by looking at the figure, we can say that PQ is perpendicular to both the lines L1 and L2. And since we have considered the equation of these two lines as vector a1 plus lambda times vector b1 and vector a2 as mu times vector b2, it is understood that PQ is also perpendicular to B1 and B2. So as PQ is perpendicular to B1 and B2, from that we can say that the PQ is along the direction of B1 cross vector B2, vector B1 cross vector B2. So we got n cap as B1 cross vector B2 divided by magnitude of vector B1 cross vector B2. And we told that PQ is a shortest distance vector. Okay, so vector means it should have both magnitude and direction. So we wrote vector PQ as B into n cap, and we got what n cap is. Okay, so when I am finding the shortest distance, I need only the distance. That is what we have taken as D. In order to find that, I use projection because here I can't measure, so I am using the concept of projection vector. So according to that, the magnitude of PQ is given by the projection of ST along the direction of the shortest distance, that is PQ. So that will be equal to magnitude of ST into cos theta. Okay, so PQ, magnitude of PQ is vector PQ is nothing but PQ, which is equal to ST into cos theta. So in order to find this, I need to find the value of cos theta. And theta is the angle between the two vectors, that is vector PQ and vector ST. So cos theta, we know the angle between the two vectors is given by vector A dot vector B by magnitude of vector A into magnitude of vector B. So I am going to use the same formula. So I have used the same formula here, and I have simplified it by substituting the values of PQ, ST and magnitude of PQ. After substituting, we got the cos theta value as vector B1 cross B2 dot vector A2 minus A1 by magnitude of vector B1 cross vector B2 into S. We already found what D is. D is nothing but ST into cos theta. So substituting the value of cos theta, we got the shortest distance between the two straight lines. You should remember the derivations and also the formula. Okay, next, this is the vector form. We should even find what is the Cartesian form of it. Now let us derive for Cartesian form. This is the vector form, that is, here the equations are given in vector form. Instead, if the equations are given in Cartesian form, that is, the line L1 is given in the Cartesian form, which is x minus x1 by a1, which is equal to y minus y1 by b1, which is equal to z minus z1 by c1, and the line L2, x minus x2 by a2, which is equal to y minus y2 by b2, which is equal to z minus z2 by c. If the equations are given in Cartesian form, then therefore D is equal to determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 whole divided by root of it is given by b1 c2 minus b2 c1 the whole square plus we have then c1 a2 minus a1 c2 the whole square plus a1 b2 minus a2 b1 the whole square. Okay, so this is the formula when they are given in Cartesian form. So now let us find what is the distance between two parallel lines. Here we have considered two lines L1 and L2 which are parallel. So let L1 and L2 be two parallel lines with equation vector r is equal to vector a1 plus lambda times vector b, and vector r is equal to vector a2 plus mu times vector b. Okay, then the lines L1, L2 are also coplanar, means they are lying in the same plane. So here we are going to consider any point S on the line L1 with the position vector A1 and T on the line L2 with the position vector A2. So take any point S on line L1 with position vector A1, vector A1 and T on the line L2 with its position vector A2. Okay, so here we know TP is the shortest distance, that is the perpendicular. So if the foot of the perpendicular from the point P from the point P on the line L1 is P, then the distance between the lines L1 and L2 is equal to magnitude of P. Okay, so let us find, in order to find, let us consider the angles here. So let theta be the angle between vector B and vector ST. So when I consider the angle between vector B and vector ST, what is that I am doing is, this is vector ST. So we have a vector B which is parallel to both the vectors L1 and L2. So I am finding the angle between ST and vector B. So this is given by vector B cross vector ST is equal to magnitude of vector B magnitude of vector ST sine theta n2 n cap. So here n cap is the unit vector perpendicular to the plane of the lines L1 and L2. And cap is the unit vector which is perpendicular to the plane of the line L1 and L2. But I can write vector ST as vector A2 minus vector A1. Why? Because vector ST is nothing but vector OT minus vector OS, where the position vector of the point S is A1 and the position vector of the point E is A2. According to that, I can write ST is equal to vector A2 minus A1. Next, let us define what sine theta is equal to from the triangle STP. From the triangle STP, let us find what sine theta is equal to. Sine theta is equal to opposite by hypotenuse. So opposite, it is given by PT divided by hypotenuse, which is ST. Therefore, I can write ST into sine theta is equal to PT. Okay, so I am going to substitute these two values in this equation. So as we are finding the distance between the two parallel lines, so when I am taking a distance, we need only the positive value. So take the magnitude for this equation. So magnitude of vector B cross vector ST will be equal to magnitude of vector B, magnitude of vector ST, magnitude of sine theta into magnitude of n cap. Therefore, here this is equal to magnitude of B, magnitude of ST is nothing but ST into sine theta into magnitude of a unit vector is 1. Therefore, this is equal to, what is ST into sine theta? We already know ST into sine theta is PT. Okay, so here substituting here also the values. So B cross ST we know, that is the vector ST is vector A2 minus vector A1. Okay, so what is PT here? PT is nothing but the distance between the two parallel lines. So I can write PT to be equal to D. That is the distance D, which is given by vector B cross vector A2 minus A1. Therefore, finally when I substitute these values, I'll get, if I consider these to be as D. So from this, I get what is the value of D, that is the shortest distance. Therefore, I can write distance D is equal to magnitude of vector B cross vector A2 minus vector A1 by magnitude of vector B. So the shortest distance between the two lines which are parallel, shortest distance between the two parallel lines.